This is the problem, you jump around. This PC,
Seems like so much fun, so I just like use it.
lesson, what was the other lesson?
Yeah, it's just right now.
You've got lesson 5 already, that's where we are. No, don't speak. Don't speak. Okay, this PC. There. This PC. Let me look at this. Listen to you want that one. Okay, start. So now you have 2 PowerPoints. You should be able to swap it. So go back to PowerPoint. There you go. Minimize it. And you've got this one.
So this still says I'm sharing.
Yes, you're still sharing. Nothing's changed. You've got to go back to slideshow and start again from current slide.
So now I should have everybody there.
It's 4:06. Time to start.
Okay. Are we all here? Woo, thank you.
One go. It's in trouble. Should call.
We'll call your name.
Right. We've got
But hopefully there'll be no
afternoon
problem.
tea later on before it. Said we need sugar tonight, so. Okay,
Now,
now,
say it again. Don't let this scare you. There's 5 things you've got to know.
Now I'm
They're the 5 key crystal systems. Cubic and the next 4. Cubic, orthorhombic, trigonal, tetragonal. That's it, 5. Yeah. And you need to know, and I've got a spreadsheet I made up from my study years ago that has what you need to know. You need to understand the 3A2, in other words, the mathematical formula that describes each one. It's not hard. You need to know 5 things. You need to know the 5 crystal systems, and you need to know the 5 mathematical symbols that describe them. And they're all A, B, and C. And it says A equals B equals C, or A is greater than B is
nods, I
greater than
like that,
C.
nods,
It's all coming back to me.
yep.
They're the key things you've got to know.
Well, actually, I will expand that. Chemistry, crystallography, and optics are the horror lectures.
Yes,
They're all back to back.
they are, and they're all back to back.
And after they're gone, smooth sailing. They're the tsunami, after that it's smooth sailing.
And the other 2 crystal systems are mentioned, but they're not
theory.
examinable.
For theory.
They're only examinable for theory, so you don't have to worry about it for practical. And there aren't that many stones in any, the key stones are in those first 5 systems, the key stones.
Okay, everyone at home can hear me?
Yes, Jen. Yeah, okay, yeah.
Thank you, that's okay.
You've got my phone number, Jan?
I do,
I'll be available.
I do, and I do apologise for last week when last time when I didn't do very well, so let's hope this week. Now, because you've got the screen this week, you won't be able to see me waving my arms around.
That's probably good.
So, no, but it means they won't see samples.
No, if you want to do that, you've got to exit where you are now and go back to.
Share the thing.
No, don't do anything with any of that. Just go back to Google and they'll be able to see you.
Okay.
But then just go back to help.
Well, this is what I thought I was doing.
I think the camera's just pointing in the wrong direction.
Oh, yeah, the camera, I didn't have focus.
Well, no, well, I was using it, that's what I was
Is that
trying
better?
to use last week. So, And yeah, you can see me.
Yay.
And you,
Yeah.
that's okay.
You will be small.
I'm dainty. Okay,
So now
That's
you don't
lovely.
have to jump around.
okay, that's fantastic. Thank you. Okay. All right. Now, I've started this sort of where we sort of got up to last week. So just quickly, I remember the 5 crystal systems in an order that to me is logical. And it's to do with elements of symmetry, really. So, which we're going to learn tonight. But the first one, which is the most symmetrical in every direction. The first one that I taught you was cubic, and it sits on its own because it does its own thing different than all the other systems. Then the next 3 that I like are the owls: tetragonal, hexagonal, trigonal. Those are the next 3, and then we have the other X, not cubic, and they are going to be orthorhombic, monoclinic, triclinic. If you break it down to bits, it's not so hard. And as Leo was saying, monoclinic and triclinic, they're horrible crystals. We don't want to know about them with respect to the Prax system, but you do need to know something about them for your theory. So when we get on to a couple of bits tonight, if you've read, and I really applaud, Febby was asking me questions because he'd read the notes, which I really applaud. But there are a couple of sections where you need to know stuff for this year, but then you can forget it. Now, 80%, 90% of the crystallography you do carry over to Gem2, and it is really important for separations between gemstones. But the elements of symmetry that we get onto, they in fact won't be important to you next year. Just this year as a basis to your crystallography. So if I'm talking about for the cubic system, some imaginary axes when I want to talk about the crystal system, what are those 3 imaginary axes that I talk about for crystallography? A, B, and C. Yeah. So which is the long axis?
C.
Terrific. Front to back? B. A. Sideways is B. Okay, so with the cubic system, we don't have A, B, and C. What do we have? All are equal. So A1 equals A2 equals A3 because it's symmetrical. In most instances, we think of the C-axis as the long one. There is no C-axis in the cubic system because they are all equant. It is a shape that is very regular and even. With tetragonal system, if I'm looking down, well, hang on. What are the names of the axes then with the tetragonal system?
A, B, and C?
Yes, but no, because the 2 lateral axes are the same. So we have A1 equal to A2, but not equal to C. So for the tetragonal system, A1 equals A2, but does not equal C. So we don't have 3 A's. We just have 2 because the one way and that way are exactly the same. So when we look down the C-axis, what shape will we see? A square. These got resurrected from the junk pile, but I like them. So this one, if the people at home can see me, if I'm looking down the C-axis, A1 equals A2, but does not equal to C. So that's easy, isn't it? And it's, what does tetra mean? 3. No.
4. 4.
1, 2, 3, 4. When we're looking down the C-axis, we see a 4-sided square, so it's tetragonal. Now, someone chose to throw all of my things out, as I said last time, so I don't have a hexagonal, but with a hexagonal system, there is a C-axis, but instead of 2 lateral axes, we have
Three.
3. So we have A1 equals A2 equals A3 is not equal to C. So the same thing, if this was a 6-sided figure, it's hexagonal because hex means 6. So when we look down the C-axis, we will see 6 as an outline. Now, if anyone at home can see me, when they're talking about these systems, they presume that when the crystal was being made from all its little unit cells, they start at the beginning and they grow outwards. They presume when we're talking about the faces that the actual axes go through the centre of a face. Okay? And that's why we say if with a tetragonal system, instead of having 4 sides, we might have 8 because the stupid crystal decides to grow faces not only through there, but through the corners as well. So for some reason, instead of growing 4 faces, it will grow 8, some that are centre faced and some that are corner faced. So that because it's grown one way and then through the corner as well, that is called 2 orders. But if it's a doubling up, then we get 4 faces or 8. And if it's hexagonal with 6 faces and a similar thing happens, how many faces could we get? 12. So if you've got 6 or 12 faces, what crystal systems could it be? Hexagonal or trigonal. Trigonal tri is 3. So the trigonal system used to be a subdivision of hexagonal, but they decided to give its own little system mostly. So the reason we might have 6 sides is because I explained last week we have prism faces. Instead of having 6 faces that react the same, we only have sometimes 3 faces that react the same. So we have 2 sets of 3. So it doesn't always react like if we had 6 equal faces. I'm going to pass around, the ones at home can't see, it's my jade bangle. I've had it for years. I don't want anyone to make comments out loud until everyone's had a look at it, but I want everybody to have a look and tell me what they think about the value of it, please. Your first gemological test. So no comments out loud, but I just want you to know where the colour and everything else is concerned, what they think of the jade bangle.
With 2 sets of 3, is that a hexagonal? Is it in the hexagonal or the trigonal?
Trigonal.
Because there's 3.
There's 2 sets of 3. So the 3 is the 3 sides. So it's a trigonal thing. So if there's 6 sides that are all equal, it's going to be hexagonal. And we cannot see that by looking at it. We just know from science that that's the way it's happened. So that the tetragonal and the hexagonal, when we're looking at what faces are there on those crystals, what forms they have, every crystal, every gemstone in the trigonal system, in the tetragonal system produces the same forms, which are prisms and bipyramids. That's all you get. In the hexagonal, and maybe a basal pinacoid, which we did last week. In the hexagonal, it's the same thing. You get prism faces, you get basal pinacoids, and you get pyramids. Now, when you get to the trigonal system, because it's the trigonal system, each of the different gemstones has a different set of forms, of faces that belong there. So we did these different definitions last year. So to be a prism face, we need to have how many?
3
or more. If there's only 2, can we call them prism faces? What do we call them?
Rocks.
Pinacoids. Okay, if there's only 2 faces, pair of parallel faces, they are pinacoids. And then we put an adjective in the front to decide which direction in the crystal they belong. So a basal pinacoid are the ones that cut the C-axis, and they're the top and the bottom, basal. a lot of the time you can work out what they mean by that. And then we get on to the other, if they're this way or if they're this way, what names we give them then apart from because they're no longer, if there's two faces the same. So there's this here. We don't have what shape's that looking down? Rectangle. So A, B, and C. Tell me about A, B, and C.
A not equal to B not equal to C.
A does not equal B, does not equal C. Because if A was equal to B, we'd have a square. Now we have a matchbox. But if that was growing, and it's growing from the middle out, if it didn't finish growing, we get the lozenge shape. Same as these poor little old things. This, in fact, is looking down. What have we got? A square. So we're in the tetragonal system. But I think I showed you last week, if it forgets to grow the prism sides, we might just have bipyramids top and bottom.
Sorry, one of the students has just put up on WhatsApp that they need to be let in, Simon Young.
Simon.
Sorry. They just sent us
Okay.
messages.
Press escape. Go back to Firefox.
Oh, so sorry. I thought it was one.
Escape. Oh, Simon, you've got to be here already. So, okay. So, Simon, where are you? Can someone tell Simon he's not here? Has he asked to join the meeting? What's he saying for us? Did he have the code? And has he tried to join the meeting? Is he talking to us?
Not replied yet. I'm just waiting.
So just, even though they can't, I'm still presenting, I think. So,
He sent a link.
that's about it. So if he follows that link, I think that looks about right.
Is it meet.google.com? And then
No, just that link. Oh, well, he can put the whole lot in, yes. Just put that whole lot into the search bar or the yeah. So with, just while we're talking with the orthorhombic again, when we're looking down the C-axis, A does not equal B, does not equal C. So we look at a matchbox, or we look at a lozenge shape. And if we're looking at that lozenge shape, there are no right angles, so it cannot be tetragonal, even though we've got four sides. If we can't find a right angle, if we can, and even if they're lousy crystals, because, you know, Mother Nature doesn't make perfect ones, if there's no right angles when we're looking down, then it's not tetragonal. If they are less than right angles, because it's stretched, remember, it's not an equal thing, it's lozenge shape because we've got a rectangle from where it's grown from the inside, there will be no right angles when we're looking at that. When you get into doing your crystallography in the prac, which is your next 2 weeks of prac, don't be frightened to ask questions like that, or ask each other questions, because that's the way you'll learn. So again, this is just showing you when we start from the beginning of the crystal and we're building all from the outside in all 3-dimensional directions, we're building these little unit cells to build up a bigger and bigger crystal. If it doesn't all end up growing all the way out, we end up with that's how we end up with bipyramids. If it forgets to grow the prism face before it starts building the bipyramids, we may just get bipyramids top and bottom like that. Do I know if that pyramid is different than the cubic system? If I've got a octahedron from the cubic system, how do I know it's not that?
Is it because it would be shorter? It wouldn't be longer?
The C-axis would be longer in this one, therefore they're not really an equilateral triangle. These are an extended, so yes, they are longer because of that C-axis and not being a quant. So if it's C-axis, you get an equilateral triangle. With this, it's an elongated, isosceles triangle, so you don't get an equilateral triangle. So that would be the difference when you're looking at something that forgot to grow prism faces in between the terminations. Cool. I don't know, I think we'll go back to the screen with Simon. If he gives us another.
So you don't send them an updated link every week?
It's the same link. It's the same link. Yeah, it's the same link. Yeah, well, I sent the link to Antonia because she said she'd lost it, but it's the same one each week. So if you can store that away somewhere, but they're not showing up, so I'm not quite sure why. I wouldn't expect so because it's just a link to go to Google, so I don't think their email address should affect if they get in or not. Wouldn't you?
Click confirm somewhere?
Sorry?
Maybe you click confirm somewhere to.
Well, I'm supposed to get a notification and then I say admit, but I don't.
You know, see that? I think there's two windows under that little red yellow icon. At the bottom, that red, that's Jen, the third on the right side.
On the
that
right
icon,
side?
I think that it's a PowerPoint icon. I think the red yellow one. I don't know.
Yeah, the PowerPoint.
Yeah, there's two windows there. What's the other window?
The other window is nothing.
It's hidden. Like, do you want to try click on it? Maybe there's like a. Not that one.
That's a Word document. I don't know.
It's on that same one. There's two underneath each other, she's saying.
Yeah, that's what I meant.
Next to it on the PowerPoint icon.
No, that's because I've got two PowerPoints open.
Oh, okay.
That's got nothing to do with coming into Google Meet.
I just advise him to just try the original link that you had sent, again, and we'll see.
I sent one to Antonia this afternoon. Because if they're there, it'll tell me to come in. Right. Well, for the moment, we'll go back and we'll give them another try in a while, because we haven't moved off this slide yet.
Sorry, Jen, would that fall under any of the systems?
Sorry?
Would that figure fall under any of the systems?
This one?
Yeah.
It does fall under one of the systems because all crystals form under one of the systems. So is A equal B equals C? What
I don't know. Where would you
what system am I looking at?
tetragonal?
Tetragonal. So that's a tetragonal crystal. Whether it looks like that or whether it looks bipyramidal, is it got prism faces and basal pinacoids? Is it bipyramidal or is it got a combination and have prisms? Little evidence of some bipyramids and then a basal pinacoid.
So where are the axes in the tetragonal system here? Like where do they go? Like to the
Through there?
Yeah.
Oh, sorry, for this face, it goes through the middle of the prism face, so through there and through there.
Okay.
But if they decided to do doubled up, they would come through the corners as well.
Okay.
So you don't need to know if it's which is the first order and which is the second order. It's just more than one order that you would see. So going back to the cubic system, what are the faces the forms that you will see in the cubic system. We just talked about one. Octahedron, diamonds and spinel. This is the summary. Cubic system, A equals B equals, A1 equals A2 equals A3. The forms, the actual faces can be octahedral.
Trapezohedron.
Well, basically dodecahedron, octahedral, or cube.
Cube. Yeah.
Okay. Did everybody have a look at my bangle? Is it good quality? Who said no? Why isn't it good quality? Sorry? It's glass.
Is it dyed?
This is the start of being good gemologist, because your eyes are your best instrument. There are bubbles and there is a mold mark in the inside. You can feel the ridge. If anyone wants to have another look, I'll pass it around. But on the inside, there is a ridge where it's come out of a mold, and there are gas bubbles, and nobody has bubbles in a piece of jade. It's glass. Sorry? Jade, oh well, most minerals will have a similar, it's warmer probably because everyone's been holding it. If it's something organic, it will be warmer, but most stones are cool to the touch, yes. If you're a prospector, because sometimes heat is dissipated through a crystal more from one crystal to another, some of the prospectors will feel it and use that as an indication for a gemstone, because one will stay cooler longer than another one. But that's not what we want to know here. Okay, so sorry?
It works.
It works, yeah. Yeah. If you're an old fossick, oh, sorry.
Stick them in the mouth.
But if you're used to feeling them, yeah. The jade people say that if you bang two jade pieces together, it's a particular tone and note, and if you do, and it's very different than if you bang two glass paste ones. Okay, that's just to highlight the fact that if I tell you it's a diamond or I tell you it's a piece of jade, you're a gemologist from now on. You don't believe what anyone tells you. You use your eyes and your lip to decide. Lesson number 1. I'll leave that off because it's genuine. Okay, so the faces that we see on the crystals, they're called the forms. Okay, the overall shape of the crystal, how it actually ended up growing, is the habit. So, did it end up sort of, in a particular, so if this was a really long crystal and its main face is prisms, we talk about that being a prismatic shape or a tabular shape. And when we're talking habit, we're talking about the entire overall shape, like the habit of a nun. What she's wearing, the outside is the habit, whereas the form is the actual crystal faces. So when you write up your forms there for crystallography in the lab, they will ask you for habit and form because they're two different things. So the habit's like the nun, it's the outside shape. The form is the actual faces. Where are they? Basal pinacoids? Are they bipyramids? What are they? And as I said, cubic has got its own set of forms. Tetragonal and hexagonal, they all have very minimal forms and they behave the same way. Trigonal we got onto last week because each of the gemstones do exhibit different types of different types of forms, as well as different perhaps habits. Oh, I just did that by accident. I just made that by accident. Did it again. Okay, we talked about the forms. That's better. Open and closed forms. We talked about that last week. So if we made a whole crystal out of prisms, the idea of a closed form means if we just use prisms, would it be enclosed by space? These are half-mark questions in the exam, okay? Some of these things, they're only half-mark questions, so you don't fall on your sword just because there's one little thing that you've missed. So this is the sort of thing that I want you to do as a summary. The forms that you're going to see in each of those 5 systems, because cubic has got a particular set all on their own that nobody else has got. Tetragonal has only got 3 different forms that it can have. This goes up on Moodle. Last year's is up there in Moodle, but I play, added a few bits, so it'll go up tomorrow. Hexagonal is like trigonal, exactly the same form. They are the 2 easiest on earth to remember, those 2. And cubic's got its own, so that's not a problem. Trigonal. Now, trigonal, again, remember we've got 2 sets of 3 faces, so those 2 sets of 3 faces means that sometimes the notation for some of those faces has to be different. So if we get a pyramid, we get a bipyramid, we get one above and one below, say a prism face. So there's a pair of them and we call them bipyramids. Now, do you remember, because we've got a quartz, for instance, where there's 3 faces, only every second face is the same. The terminations, the one above and the one below, are not going to be the same animal. Therefore, they can't be called bipyramids. They are called rhombohedra. Rhombohedra, because there's one there and there's one there, because it's not the one, it's the next one around, because of this 3 sets of 2 faces. So they're not above and below the same ones. We saw that in the other diagram. If we're talking about tourmaline, tourmaline can be 6-sided, mostly it's 3-sided. And with the tourmaline, we know that it produces, it's one of the few gems that produce a different set of faces at either end. So on the bottom, we call it, there's only one face, it's a pedian. Remember from the previous thing, oh, sorry, I won't go back now. If there's only one face, it can't be called a pinacoid, because you've got to have a pair to be a pinacoid. So with tourmaline, if it has a different face at one end of the C-axis and the other, then they have to have different names. So the bottom face, because it's a flat one, will get called a pedian. And the top ones, because there's no thing up and down, they can't be bipyramids, and they can't be rhombohedra because there's only 3 sides. So they tend to call them trigonal pyramids, not bipyramids. So trigonal pyramid is just the one that's on its own, because there's no thing down below to make it a rhombohedra or a bipyramid. So they refer to them as trigonal pyramid. And bipyramids are not often terminations, but they can be in corundum, ruby and sapphire. So with the trigonal, you have to actually have a little list yourself about what are the faces for each of the gemstones, like really cubic, because diamond and spinel are always octahedra, or usually, mostly octahedra. Dodecahedron, either pentagonal or rhomb, are only the garnets. So it's a bit like the trigonal system, where particular forms are for the different gemstones. And when we get to orthorhombic, we can have prisms if there are 3 or more faces the same. If there's only 2 the same, we get to pinacoids, and then we can have domes is the older way of describing it. And if you don't want to talk about domes, you can talk about horizontal prisms, which is a bit more difficult to explain, but you can do that later on once you get to know it. So again, if you can write up some of these summaries on little cue cards, it's like having a little cue card for 5 minutes of study with your definitions. It really does sink in, just 5 minutes here and there. And I find if I say it out aloud, then, like tell a tree, tell your dog, whatever, it means that you're hearing it as well, and so you get this reinforcement. So if you say it out aloud when you're studying, walk up and down the path or something, I think you'll find that quite works. So there's our shapes for the cubic system. So this one on here, that happens to be a diamond. Now, when diamonds usually come out of the ground because they've come up in this horrible magma that's very acidic, very hot, very volatile, they get eaten away, so you get this grey skin on them. So it doesn't look like a nice white little diamond at that stage. The only time you get one that looks like a diamond is if it's been encased in some of the host rock. When it comes up, it's been protected from the magma, and then we call it a glassy. Not that you need to know that, but that's mostly they will come out of the ground, and if they're not a perfect shape, it's to do with other factors. This one next to it here is a spinel. Spinels always come in that colour. In that shape, not in that colour. So, but as I said last time, don't worry about it being, don't worry about the colour, because you can't judge on the colour because you'll get different colour things. Here is the shape of this four-sided figure on that. So that's a rhomb, dodecahedron, and this is the cubic system, which is your irides. Now, fluoride, if you remember, even though we haven't done cleavages yet, fluoride is one where there's planes of weakness, and if you drop it, it starts life in the ground as a cube, but if you drop it, it ends up looking like an octahedron. So they are not crystal faces, they are cleavage planes, but the rest of them, they're their crystal faces. There basically is what you get with your bipyramids sitting above your prism faces, mostly, and that's the shape that you will get. So if you look down that C-axis, what I tend to do is I look down the C-axis, and if it's a broken end like this one here, I'll often look down the broken end first, so you're not distracted by terminations, and you can just see the outline to see what it is that you're actually looking at. Have we got 4 faces? Have we got 8? Have we got 6? Have we got how many? And use your loop. So you can both see with this, we can see 2 faces. We know there's a 2 on the other side, and there will probably be 4 terminations for the bipyramids. So we have prism faces and we have bipyramids there. Easy peasy. Hexagonal system is the same. If we look at this crystal, you can see 1, 2, 3, 4, 5, 6 faces there. When we look down that axis, you can see clearly there are 6 faces. And we have prism faces because there's more than 3 the same, and basal pinacoids, okay? Otherwise, we might have bipyramids. Sometimes with an aqua crystal, you'll have just tiny little remnants, which is why you use your loop. You might have just the start of tiny little bipyramids. And if you have tiny little bipyramids, Amy, you should be going home. You need to mention those. So if you don't look with your loop or good eyes, you might miss some of the forms that you need to tell them about when you get into the lab. There was our quartz system showing you that. M is the pyramids, the prisms, and because of this 3-sided, 2 sets of 3, we can't, that Z, that face there is the same as that one. We've not got one top and bottom, so they cannot be bipyramids because of this 2 sets of 3, 2 lots of 3. So that are, and there's another one over there. So if we look right down, you'll see one pattern. If you look from the other end, you'll see slightly different because the Z's and the R's are at an angle to each other. So they are rhombohedra. Okay. Now quartz is really different too, because sometimes you get these extra faces here, and that's because the way the quartz grows, it's got this circular system of its growth. So sometimes it can grow one way, sometimes it can grow the other way. So we talk about left-handed and right-handed crystals. So in this instance, we've got a major prism face and a major rhombohedra, And on the left-hand side between those, we have got an extra face, and that's telling us that crystal is left-handed. If it was a right-handed, that extra little face there would be over this other side here.
Is it a girl or a boy?
Well, this one's girl because I'm using a pink mouse. So, so we can have this one here is the trigonal, even though it doesn't look like a pyramid because it didn't finish its growth, it's got a funny shape.
Would that
And-
change though if it was just the upside down?
These little ones, no, because that one would have one over here. So if you turned the crystal, if it was doubly terminated and you turned it upside down,
Yeah.
it would be over here as well. So it wouldn't matter which way you turned it. But mostly you don't see doubly terminated quartz, so you've got to work from one direction anyway.
Okay.
There is one variety of doubly terminated quartz. If you go to Herkimer County in New York, you can find Herkimer diamonds. They call them Herkimer diamonds, but it's quartz. But it's doubly terminated and it's quite clean, so it looks like a diamond.
They have those in Tasmania, some kind of that they call a quartz. What's it called?
Topaz.
Is it topaz? What's it
Yeah.
called?
Something.
Kill something.
Killer cranky. Killer cranky.
Kilcranky
Diamonds, and it's
Yeah.
it's topaz.
Yeah.
So these are names that they
To
just.
get the tourists.
Yeah, it's really.
So the other thing you need your loop for is because there are external features and internal features on some of these crystals. So quartz, except for Herkimer diamonds, on these prism faces have horizontal striations, and that's a clue because others of them will have vertical striations. So for your theory, you just need, you need to know perhaps that this is a bipyramid and this is a trapezohedron. It's not guaranteed that it looks like a bipyramid just because it's been crowded by other things around it. And in a quartz system, you don't get it as a termination, you get the rhombohedra. So if it's stuck in the middle there, you can get a trigonal bipyramid, okay? It looks like, to help you remember, perhaps you can say often it looks like a little rectangle. Maybe that's two pyramids. Bipyramid makes a rectangle. I don't know. You think of it. The good thing about studying is you find silly ways to remember things, like me saying about an anion. And if you a negative ion, if you find funny ways to remember things, it helps.
What's the thing about rhombohedra? But they are different. How are they different? Do you know this? Do you understand that?
I don't understand any of this.
You sound like you know what you were.
Okay, now
So could
we
you,
were talking earlier. There's a lot of stuff on YouTube, especially when we get onto symmetry. There's a lot of stuff in there. But George was saying if you just do crystallography, it's all a bit of a mess. So you have to put gemology and crystallography, and if you combine those two in your search engine, things come up. There's always the Gem1 website in YouTube. If you Googled YouTube Gem1 crystallography, there would be things that come up, or GIA crystallography, or whatever. You search that way, you're likely to come up with all sorts of things. So
Sorry, just one more thing about the rhombohedron. So the bipyramid is when you have the termination point and you have the equal facets either all the way or every second one, right? What's the rhombohedron?
So the bipyramid is going to have one above it and one below it. But because these aren't 6 equal faces, the one above is not the same as the one below. The one above is equal to this one here because we've got 2 sets of 3 faces. So the rhombohedra as a termination are only in the trigonal system.
Okay, thank you.
Only in the trigonal system, like domes are only in the orthorhombic system. Dodecahedra for a garnet are only in the cubic system. So you can put these on little cards. The more you do it, the more you stay. So trigonal system, we have a ruby. Now sometimes the ruby will have a nice elongated C-axis, and then because Mother Nature hasn't read all the textbooks, sometimes we get a tabular crystal. So in this particular instance, the C-axis isn't the long one, but you still get used to looking down to find a six-sided figure, okay? So when we look down or on this one, you will find that you've got perhaps 6 sides, so it has to be one or the other. If you know that there's only a couple of gemstones in the hexagonal system, you have to know for practical purposes, and only a couple in the trigonal, then you can work it out. For instance, working backwards, you're not going to get a red stone like that in the hexagonal, because we look at beryl, which is aqua, emerald. You're more likely to get those colours than you won't get a red beryl, I can tell you, because they're much too rare for us to have anything like that. So if it's a red stone like that and it's got that shape, it can't be anything else than the trigonal. 6-sided, but it's not going to be hexagonal because you don't have to do a red stone in the hexagonal system. Okay, this is for your practical purposes. So this one on the top, there's one above and one below, so there's 2 of them, so we've got basal pinacoids. But we've got R for rhombohedra because there's not necessarily one below, it's there and then it's there. So if we look carefully, we've got those 2. They will be in different allocations below, so they are rhombohedral terminations. But sitting above this crystal, this prism face, we might have one here and there'll be one below it, that little one there. So that's a bipyramid because there'll be one above and one below, separate than these rhombohedra. Okay, so N and N are sitting above each other and above the prism face, so they're going to be bipyramids. You don't see them very often, but we need to tell you that sometimes they're there because the major ones you will probably see will be these rhombohedra.
The rhombohedra are always opposite each other, and biopyramids are
above and below each other. Yeah. So sometimes you're very lucky to get a crystal like this, which is nearly 6-sided. But look at that when we're looking down the C-axis. Can you see that thing there? The little triangle? That is telling you, it's called a triangular growth hillock, and it is telling you what the internal structure of the system is. It's telling you it's trigonal. Okay? So sometimes with a ruby crystal, you'll be lucky enough to see a little evidence of that triangular growth hillock looking on the C-axis, and that's a dead giveaway. So, and here we're looking down the C-axis, we can see the 6 sides. Here we can look at the 6 sides of it. Anyone want to buy that ruby? No.
Jen, can I ask you something? I've seen a yellow sapphire that's cut, and in the middle of it, it's got a bunch of blue triangles. Is that remnants of it growing? How did that happen?
Are they really triangles?
Yeah,
They're not just little blobs?
No.
Okay.
I can show you a photo.
Yeah, if they're a little blob of blue, when a lot of sapphire are forming and there's differences in the mother composition, you need lots of iron and titanium to make the blue. If there's just iron everywhere, you'll get yellow. So if there's a lot of iron there, but the iron and titanium are only in little bunches, you can see evidence of blue patches. Sometimes from Sri Lanka we'll get one where they cut it out, the whole lot of it will be colourless with a patch of blue, and they cut it accordingly. But if they're blue triangles.
So it doesn't have anything to do with the way the crystal formed before it was cut?
I would expect it's either something to do with colour, but if it's a really distinct blue, are they some sort of blue crystal in there? I'd have to look at the stone. But probably not, because normally if it's to do with colour, I'd expect a bit of a patch or a band, but not something that's very definitely.
Perfect triangles.
Have to show me. I'm interested. Okay, now again, trigonal, and often, sometimes rubies, but a lot of your sapphires will look like this, and we call it a dog's tooth, because it can't make up its mind. It wants to go pyramid and bipyramid and pyramid and bipyramid and pyramid. So we get this overall shape. So we can call it barrel shapes, or we can call it bipyramidal the whole shape of it is bipyramidal rather than, so that's like the habit is bipyramidal, not the faces, because we kept trying to swap. So it kept growing little pyramid faces. So that overall thing, but you might get evidence of rhombohedra. This is why you look with your loop. You might have 1, 2, 3 showing you rhombohedra, or you might just have all of these bipyramids. What's the top one going to be called again? Basal pinacoid, because there's 2 of them, one top and bottom. So here, look, there's a little one top and bottom. So we do have basal pinacoids, but the whole form is called bipyramidal or dog's tooth because it's been broken in half. Some of these you can see differences in colour because of what has been available when it was growing with respect to iron and titanium or iron as trace elements inside the development of the corundum. So this is all in your thing for the website. There shouldn't be a problem with this when you're, and lots of pictures like this just for you to get a view of it, and hopefully those that have got photographic memories will see trigonal system, sapphire, and then see the dog's tooth. Okay, now again we've got tourmaline, sometimes 6-sided, sometimes 3-sided when we look down the C-axis. Again, we mainly have the terminations are going to be called a pedium on the bottom and trigonal pyramids, not bipyramids. I know it gets confusing because we want to call different things different ways, but it's the convention that's been there, okay? We used to try and call these terminations rhombohedra, but then we were told, well, they can't really be rhombohedra because there's none down the bottom because it's got a pedium down the bottom, so we can't have rhombohedra really if we want to be technically correct with a tourmaline. So looking down the C-axis, you've all probably heard or seen watermelon tourmaline. There's another one called lidicodite where because of the trigonal system we get this design that looks like the Mercedes logo, and you see this evidence of the 3-way again because it's a trigonal system. And tourmaline, if you can see there, has sometimes got vertical striations. So again, you've got to look with your loop at the outside as well as the inside because a quartz is never going to have vertical striations. So these are the clues for when you're trying to identify something. Now orthorhombic, people have orthorhombic, they have trouble with it. There's only 2 that you have to know about, and that is Damburite and topaz for purposes of prac, and we have there, they are the list of faces that you can have. Now, so with a topaz can be like this, where you've got a matchbox shape, but then we can grow other faces because when it started from the inside and grows out, we can have this combination of faces. So the combination of faces means that topaz can grow a lot of different faces, and there might be quite a few of those forms that you can see in any one crystal. But one of the things we do see is when we're looking, remember, front to back is shorter, B is longer. So on this crystal here, we've got it set that way because front to back is short. That's the long side, and there's usually a dominant face. If it's lozenge shape, like this one will be, and we've got the long angle that way, we've got 2 dominant faces sitting sideways there for a topaz, which is different than a Damburite. There's the long face, and it's the front face that's a dominant one. One clue, because we've got this dominant, again, if we look down the C-axis, we're going to see a diamond shape, but we've got this dominant front dome, whereas with if we have the lozenge shape, there's a dominant side dome there. Okay, if it's a rectangular shape, well, if it's a rectangular shape, you've got prisms, or well, like because this. Well, have we got prisms?
Yeah.
We've got that one and that one the same, and those 2 are different. But if there's more faces than that, we can have prism faces. So on this one here, I imagine if there's that one and that one, although that's a secondary crystal over there, but there could be 4 faces and 2 faces there and 2 faces this side, and then pinacoids as well. So it's not difficult, again, if you know your definitions of what they are in there, because there's not so many different ways that they present. Now, if it's something that's like this, it's not going to be square looking down, it's going to be matchbox, and you will get right angles, but it's matchbox rectangular shape looking down, not square looking down. So if it's got right angles because it's a squarish looking thing, but it's actually a matchbox, then it's orthorhombic. If it's square with right angles, it's tetragonal. I know it's a lot, but again, if you do your definitions, it does fall into place. Trust me.
Is it snake time?
Is it snake time?
That's what I'm waiting.
You wait, then you call it very soon, very soon, very soon. So the other one that you might come across, which is out of left field, is this one here. Normally they can, if it's like that, you might see it. And again, it's orthorhombic, and you won't probably see it like that, but it's got a dominant side bit there. But chrysoberyl wants heat and pressure makes it do what we call twinning. So it starts to intergrow. There's this intergrowth between a crystal, and so it ends up looking like a flower. So it ends up with 1, 2, 3, 4, 5, 6 points. So your first reaction would be to say, oh, hexagonal, but it isn't. It's actually chrysoberyl looking like that, because these little indents here is evidence of what we call twinning, which we'll do in a minute. And so even though it may look like that, it's got all these lumps and bumps, and actually chrysoberyl is the only one you have to know that does that.
How does it form again? Because of the crystal?
It's to do with twinning, which is next on the list. So this is called, it's pseudo-hexagonal in form, in sort of habit, sorry, not form, pseudo, because pseudo means like. So it looks like hexagonal with its overall habit, but it's actually called cyclic twinning because this crystal has grown on itself, more than one crystal, and we'll come to that in a minute. Okay, monoclinic you can look at yourself. It just means that we don't have a lot of angles that we want to have, like no right angles, because when we're talking about A, B and C, we're talking about the axes, but the angles between them mostly are 90 degrees, except if we're talking about hexagonal, it's 90 degrees with the vertical axis, but because we had 3 other axes there, 120 degrees each. Okay, the habit, as I said, is what the crystal actually, the shape of the overall crystal, and we will ask you what the shape will be. So prismatic is obvious. It looks like it's a prism looking shape. If it's cubic, it's going to be equant, or it's going to be blocky. Acicular just means needle-like. So sometimes if you go to the crystal shows and you look at all those lovely inclusions you can see rutile inclusions in quartz. They're long. We call those acicular because they're needle-like inclusions. So we can have inclusions that are needle-like because they're a mineral, or we can have the overall crystal having a particular shape. So they can ask you, see tabular is this squished one from the C-axis. Massive just means like rose quartz, you get a big blob. A geode means like a vug, V-U-G or V-U-G-H, which means there's been a break in the rock, and so it ends up in a little cavity. Fibrous, well, we all know what tiger's eye looks like, do we? Where there's all these parallel fibres, so it looks like fibres, okay? Dendritic is something like if you see moss agate, it's not really moss inside there. They are green crystals, but they grow in this pattern like branches of a tree. So druzy just means tiny, tiny little crystals, because I showed you a picture of uvarovite, I think, last time, tiny little green garnet crystals on a base rock. So if you know an example of prismatic, an example of what each of these be for your exams. It's a minor thing, but it is something that will come up. Botryoidal means bunch of grapes. That's bunch of grapes.
Where's that?
Botryoidal, here. So when we look at malachite, we get these sort of circular patterns where there's been a change of how much copper's in it, and we get these bands. That's showing you the shape of the crystal itself. So that's been a cabochon cut, and we've got rutile in there. So they are classed as acicular because they are needle-like inside. There's botryoidal, like a bunch of grapes. So that's the way. So again, it's crystalline on the inside. What's the definition of crystalline?
An organized structure.
At an atomic level, yeah, an orderly and repeated atomic structure, yes.
And they don't have a form. They don't have a habit.
They can have forms and habits if they're crystals,
Yeah,
but crystalline has the internal but no external.
No external form.
Yes, exactly. Cool.
So this would not be a crystal form.
That is a habit. That's how they grow. Like the outside of a nun in a black outfit. It's what she looks like from the outside. Kyanite is a pretty green stone, but trouble with cutting or anything else, but it's like a blade, like a knife blade, so it's long and skinny. And the inclusions can be described as dendritic. These are other ones. Now again, U means good and means no, bad. So hedral means talking about well-developed faces. So euhedral for a crystal has got beautiful crystal faces, and hedral means maybe it's been running down a river for the last 25 million years and it's got very poor external faces. You can still see the crystal shape, but it's not crisp and good. And hollow hedral means it's got all of the full symmetry, which we will get to in a minute. Hemi means half, so you're only showing half the crystal faces that it could show. Hemimorph means the form, okay? So it means that you can have different forms at the opposite ends of a crystal, like tourmaline. Two more definitions, they're easy. Pseudomorph means alike. Again, it's been a morph of form, but it's like something else. So when we've got tiger's eye, we've started off with an asbestos product, and somehow or other, agate has gone in, quartz has gone in and taken the place of the asbestos that was there. And so tiger's eye is a pseudomorph because it started life as crocidolite fibres and they've ended up as quartz fibres. So this is an opal, what we call an opal pineapple, because they believe it started off that was actually a crystal of ikite, but you don't need to know. This is just an explanation. And for some reason, the opal has gone in and replaced the original mineral that's there, and so it's a pseudomorph. Poly means many forms. So what's diamond made of? Carbon. Is there any other mineral that's made of carbon?
Graphite.
Yeah.
Graphite. So they're both made of carbon. What the hell's the difference? The heat and pressure when they've been formed.
The bonding is
The bonding is very different. So once diamond's in the cubic system, graphite's in the hexagonal system, and they have very different properties. So polymorph means the carbon can be two different things. So marcasite and pyrites are actually polymorphs because it's got the same formula, iron sulfide, but it's grown in two different crystal systems. So same formula, different minerals. So if we have opal replacing a shell or a bone or a dinosaur bone or something, and we have got some in museums where they've replaced an old dinosaur bone.
Oh, how does that happen?
What?
That it replaces a dinosaur bone.
Well, the dinosaur bone's been there first, and with time, when it's got sort of very loose, the opal's just taken over the form when the dinosaur bone was going to fall to bits.
Cool.
So you can have a dinosaur crab claw and shells. You know, we get our opal from the Great Artesian Basin, but it just goes to show that at some stage it was all underwater because there's shells there. Okay, and here's tiger's eye because we've had the quartz fibres replace the crocodilite fibres there, and so we get this lovely sheen with the parallel fibres that are now quartz. So pseudo means like, as in poly, which means many forms. So the poly means we've got more than one form for a particular formula. So that's what the original crystals will look like, and then they're replaced by the opal, and you get a whole different look. Okay, just quick revision, then it's frog time. Okay, this is stuff that you just need to know, because this is what we get on, and this is where your eyes will roll, and you'll decide that you hate crystallography, but this is a very small part of it. And after Gem 1, you don't have to remember it. Just this year. And as I was saying earlier, if they ask you about any of these symmetry elements, you might have a question on quartz or something that's 5 marks or something in your exam. One of the questions might be, what's the minimum symmetry for this crystal or this system? If you don't know, you've probably lost half a mark. Okay, so it's never going to be a major question. So whenever you're doing exam technique, you do all the ones you can do. You don't waste time getting in a knot about the ones you can't do. You do all the ones you can do, then you come back and think about the other ones. And if there's one you can't do and it's only going to be half a mark or 1 mark, have a guess. Have a guess, yeah. Although I hate when you mark it and you do that. People put all sorts of things down, and if you don't know, you've got to go and look them up. Can somebody clear that for me, please? Clear it open.
I just use teeth, so.
Oh. No, won't use teeth. Sorry, this lesson. The workbook.
The questions don't seem to really match what we're learning. So I'm finding it hard to understand the questions and how to apply what we're learning to answer those questions.
Some of the questions are to see if you understand. For instance, I've got an emerald. Is it a mineral?
Yeah.
Okay, here's your definitions. Made by inorganic nature, properties that vary with direction, and it's got a regular pattern of orderly makeup to make your crystal, yeah? So I've got an emerald, so we know it's got a formula, we know it's homogeneous, and that emerald is probably going to come out as a prismatic crystal with prism faces, basal pinacoids, and bipyramids. If I find an emerald from Torrington in New South Wales, or an emerald from Afghanistan, or an emerald from Colombia, are they going to have the same physical, chemical, and optical properties?
No.
Within range.
Within very narrow limits, because they've all still got the same formula. They've all got the same mineral. They're the same mineral, and they've got the same formula, the same crystal structure. So therefore, aquamarines or emeralds, no matter which part of the world. So this is the idea of getting used to your definition so you understand what we're talking about with some of these things. They will make more sense once you've done your some practical, and you get 2 practical lessons on your crystals. So if you, as I say, if you want some crystals to play with at home, by all means, we can get some, or you can buy some. Go to the crystal fairs if you like. But if you want a set with mainly the crystals you need for the lab. Now, There is still a student's handbook. I don't believe it's gone up into Moodle as yet, but it gives you a whole list of all of the crystals, for instance, that you need to know. So things like cyclic, pseudo-hexagonal chrysoberyl, something like that. So you need to think. Now, if you want to get up, I can stop talking for 2 minutes. If you want to go get a drink, pit stop. No, not to the pub for a beer, you won't even come back. No outside for a smoke because you might not come back. But truly, after we get past this in optics, you'll be fine. And optics isn't difficult. It's fascinating, but it's different. So once you get past the optics, everything's fine. It's just because it's new. It's because it's so new.
No, it's also because age has something to do with it.
Age. No, and the main thing is study and revision techniques and how you apply yourself. And repetition because the first time you learn something, you retain this much. After 3 days, it's going right down. But if you do the second bit and you learn again, each time, you retain more and more.
But then you're building on the previous one and the previous one.
Doesn't matter. Repetition means that you will keep it there.
Repetition with revision. So
Yeah.
don't repeat the same mistakes twice.
Out loud. Out loud. I will try again. Are they still waiting? Are they? I'm not sure. Because they've got to be, I will. Thank you.
I know it's not environmentally friendly. I feel really bad, but
I know you need it.
I don't know why they're not showing up because they.
Yeah, you need
and
it.
I do it like.
Yeah, no, it's good.
They're just not showing up as there, unfortunately. I don't know why. Because I think you'll find it's the same
But I'm gonna
login
go and
details that you guys have used.
Yeah, I think that's a
So,
good idea.
and Antonia said she was here by 6. Look, we'll get better at this. I'm really sorry. Yeah. Oh, cool. All right. Yeah, that's a good idea. Although you're supposed to ask because there's a lot of people might not want to have it recorded, like as in other people there. But if you've recorded it, yeah, you can give it to her because at least she can watch, she can change, she can listen to it. Yeah. Okay. Thank you for that. But they're not showing up, so I don't know what the problem is there.
Take 2 minutes ago, I literally just done it. And then we use WhatsApp. Yeah, and then last night. I don't know, I just get like a million kind of sudden diamonds on it, so I never do get any messages. I don't know, it's just like got
Okay.
some kind of virus.
There's only 2
Wherever I get my number from.
Now,
Hello, sir.
we
Yeah,
haven't actually
yeah,
covered
yeah,
that so
I have
much.
that.
Where's your other one? Where's your other one you were doing? This one. Now remember, if it's a bipyramid, they usually sit above a prism face, and there's one above and one below. So N will be pyramids because there's one above and one below. They're just interlopers. So really, above and below that prism face